मॉर्निंग आउ पिलाने केमती अच्छे सब जा बहुत भले थी एत दिन है क्लास फ्लास किसी लंबा छुट्टी बुझेगा पृथ्वी सारा लोक लॉकडाउन सफर कला बेलू नो डाउट ऑल द स्टूडेंट मस्ट हैव एंजॉयड दिस पीरियड ओके लिव इट एंड वेलकम ऑल ऑफ यू टू दिस टू आवर फर्स्ट क्लास फर्स्ट we can't say it as online class, let's say it as first video class. आ तो हम पाखे किसी बाट ना आ कौन करवा केबे क्लास खोलिबो कौन हम किसी ठीक ठिकाना नहीं ओके सो आमर सब नॉर्मलाइज हैला पर्यंत क्लास खोलला पर्यंत दिस वीडियोस बहुत कम हेल्प करिवो ओके still enjoy these videos okay so today in this first class first we'll discuss what we have discussed previously खास करके हमर सेकेंड ईयर पाठ कौन कौन सब डिस्कशन सब करिचे ओके तो सेकेंड ईयर पाठ रे हमें पढ़िया स्टार्ट करथिले फ्रॉम द इलेक्ट्रिक चार्ज इन द चैप्टर इलेक्ट्रोस्टैटिक्स so in the chapter electrostatics we have discussed electrostatics. First we have discussed about electric charge. Again in electric charge हम कौन सो पढ़ी थिले जे इलेक्ट्रिक चार्ज रे पढ़ी थिले खास करके how the charge comes into arise how we can say how the concept of charge came why the charge of electron was taken as negative, why the charge of proton was taken as positive, and why it was considered that there is no charge for a neutron. All the things we have discussed, and we have also discussed how the force between two electrons varies, how the force between two electrons varies, that means the gravitational force between the two electrons, how it is very much stronger than the actual force between two electrons. Like this, the gravitational force between two protons is very stronger than the very weaker than the actual force between the protons. All the things we have discussed. Like this, if two electrons will be separated by some distance apart, first we have calculated what was the gravitational force. Gravitational force means the force equal to how much? Force equal to G m1 m2 by r square. Okay, like this we are calculating the gravitational force. All of you know the value of the G, gravitational constant. This is the mass of the first charged particle, first body, and this is the mass of the second body. Here the body is the electron. So the mass of electron, what is the mass of electron? Mass of electron was mass of electron. Then we have discussed mass of proton, mass of neutron. What is the mass of electron? 9.1 into 10 to the power minus 31 kg. Okay, mass of proton 1.672 into 10 to the power minus 27 kg, and mass of neutron equal to 1. It is little bit higher than the mass of the proton, 1.675 into 10 to the power minus 27 kg. Okay, then we will put the mass of electron here also mass of electron. If you will take the distance between the two electron was 1 centimeter, then we are calculating what is the gravitational force, but actually experimentally the force was much more greater than this. Okay, I think we have discussed the force was 10 to the power 42 times greater than this gravitational force, and from this concept the concept of charge came into arise. Okay, so finally the charge of electron was assumed as negative, charge of proton was assumed as positive. What is the charge of electron? Charge of electron was 1.6 into 10 to the power minus 19 coulomb. Charge of proton was 1.6 into 10 to the minus 19 coulomb. Here it is negative, here it is positive. It has just assumed the charge of electron as negative and the charge of proton was positive. Okay, and what is the charge of neutron? It is neutral, 0. Charge of neutron is 0. Okay, all the things we have discussed in the chapter charge. Okay, also we have discussed that what are the properties of the charge also. In electric charge chapter, what are the properties of the charge, including the unit and dimension of the charge. What are the unit of charge? Unit of charge. Unit was MKS unit. MKS unit. We are discussing about the coulomb and CJS unit. CJS unit. There are two types of CJS unit. Okay. Can you remember there are two types of CJS unit? One was the ESU and another is EMU. Electrostatic unit, electromagnetic unit. And the electrostatic unit of charge was start coulomb and electromagnetic unit of charge was half coulomb. Okay, later on also we have discussed the relation between the coulomb and start coulomb, relation between the coulomb and half coulomb. Okay, again in electric charge, what are the properties? What are the different properties of the electric charge? Just like the properties of electric charge, frictional electricity. Properties of electric charge. In properties of electric charge. Okay, there are different points. हम बहुत गुड़े पॉइंट पढ़ते एक नंबर 2 नंबर 3 नंबर एभला सब पॉइंट पढ़ते से सब लिखिथिबा आमे जे चार्ज रो यूनिट कोन डायमेंशन कोन चार्ज जे स्केलर फिजिकल क्वांटिटी हाउ द चार्ज डज नॉट डिपेंड अपॉन द स्पीड इनवेरिएंस ऑफ चार्ज unlike the mass depends upon the speed. If a body moves with very high speed in comparison to the speed of the light, its mass may vary, its mass will increase. Like this, there is no change for the magnitude of the charge. Okay, so another some properties, important properties we have studied, the frictional electricity. How due to friction the charge is developed in a body due to the transfer of electron and proton. Okay, another characteristics of study properties that the force between the charges, attractive and repulsive. To equal charges repel each other, to unequal charges, positive and negative charges, attract each other. Okay, another important property was invariance of charge. That means the value of charge does not vary with respect to different frame of reference. Okay, another property was conservation of charge. Conservation of charge. That means what? That means the total value of charge in an isolated system it always remains constant. That is the conservation of charge. Okay, we can say the total charge of our universe is always constant. Charge may transfer from one body to other body, but its value will not change. Total value will not change. Another important property was induction, charge by induction or induced electricity. Induced electricity. Another was charging by conduction. So these 3 points can be studied in a single heading, that is the process of charging. There are three processes of charging. One is charging by conduction, second is charging by induction, third is charging by friction. Okay, so this can be a question, what are the process of charging. Okay, and another most important properties we have studied was quantization of charge. In quantization of charge, what is quantization of charge? Quantization of charge is that the basic fundamental charge particle, the fundamental charge particle is the electron, and the charge of any body, charge of any particle is just an integral multiple of the charge of an electron. This is the quantization of charge, or we can say in mathematically, charge of a body is equal to n into E. Charge of a body is equal to n into E, where n is an integer, n can be written as 0, plus or minus 1, plus or minus 2, like this. It is an integer, not a decimal number. It cannot be 1.2, it cannot be 2.5, like this. Pure number. It is a pure number, maybe positive, maybe negative. And E is the charge of the electron. What are the charge of an electron? 1 minus 1.6 into 10 to the minus 19 coulomb. Okay, so these were these things has been studied in the charge or properties of charge. Okay, also we have done some problems regarding this Q is equal to Ne. Already we have done. तुम खाता देखो जान परियो क्वेश्चन हैला. Then under electrostatics, next chapter was electric force. Okay, electric force रे हमें सब कौन पढ़ते हैं? Electric force. In this chapter, हमें पढ़ती जे force between two charged particles. दीटा charged particle भितरे केते force हबो? दीटा charged particle को केते distance दूरे रखले ता भितर force केते हबो? दीटा charged particle भितरे distance जदि हमें बढ़े दबा, then what will happen to the force? If the medium between the two charged particles will change, then what will happen to the force? How the force obeys which law? And from the starting, I am पढ़ी चे Coulomb's law. Okay, so Coulomb's law is the law which only says about the force between the two charged particles. Okay, so Coulomb's law कौन पढ़ी थिले? Coulomb's law रे हम पढ़ी थिले जदि दीटा charged particle अच्छी Q1 and Q2 having magnitude Q1 and Q2 and separated, and the charged particles are separated by some distance r. Okay, and let this medium is in air. Okay, leave about the medium, any medium. We can say it has any medium, maybe air, maybe any other medium. Then force. What are the force? Force equal to beta Q1 Q2 by r square. Beta Q1 Q2 by r square. So force is directly proportional to the product of the magnitude of the two charged particles and inversely proportional to the square of the distance between the two charged particles. Okay, and what about the beta? Beta is a constant. Beta is a constant like in gravitational force. Force is equal to G m1 m2 by r square, and there the G was a constant, and that G was considered as a universal constant. But here the beta is not a universal constant. There is different value of beta for different medium. There is different value of beta for different systems of units. Okay, already आम beta विषय भी कही थिले. Beta रा value को टेबल करी कही थिले. So value of beta what will be its value for air or vacuum or we can say free space, and what will be its value for any other medium. Okay, for MKS system of unit, for CGS system unit. Okay, এই ভଳିয়া টেবল করি কইଥିଲେ মো ডিটেল कहूनी এই ভ্যালু सब तुम माने जानछ खाता देखले भी जानि परिबो जे बीटा रो वैल्यू एआर पाई इन एमके सिस्टम वाज 9 1 by 4 pi epsilon 0 9 into 10 to the power 9 for CGS system 1. Okay, बुझियला for any other system it was 1 by 4 pi epsilon 0 into epsilon r. This can also be written as 1 by 4 pi epsilon, only epsilon. Also it can be written as 1 by 4 pi epsilon 0 into k. So these different terms गुड़ा को कौन कौन कुहा जाए से गुड़ा की भी हमें कहिचे. Okay, एठी कोन लिखि परिबा. Here you can write this value will be 1 by this equal to 9 into 10 to the 9 by epsilon r. Here it is 1 by epsilon r or 1 by k, like this we can write. Okay, so ame tapare koithiba je what is this epsilon 0. Epsilon 0 is called as the permittivity of free space or the permittivity of the air, or we can say the permittivity of the vacuum. What is its value? तापर ता value भी पढ़ी छे. Value ले केते 8.85 into 10 to the minus 12. तापर तार यूनिट भी पढ़ी छे, तार डायमेंशन भी पढ़ी छे. Okay, just खाता चेक कर हम केमती पढ़ी छे, how we have taken its unit, how you have found out its dimension from the formula. Always unit and dimension will be taken from the formula. Okay, like this हमें बीटा रे भी यूनिट और डायमेंशन भी पढ़ी छे, सेटा भी देखो. Okay, so epsilon 0, what is epsilon 0 is called as, what is its value, what is its dimension, what is its unit. Like this, what is epsilon r? It is the relative permittivity of the medium, of any medium other than the air or the vacuum. Epsilon r is the relative permittivity. Okay, what are the k? The value of the k is same as the value of the epsilon r, but k is called as the dielectric constant of the medium. K is called as dielectric constant of the medium, and this epsilon, only epsilon, which is equal to epsilon 0 into epsilon r, and it is called as the absolute permittivity of the medium. Okay, एगुड़ा सब पढ़ी जाए आगु सब पढ़ी जाए. जस्ट मु तुम मानु के मन पके दउची आ खाता भी देखियो तुम मानु कहूछ आ तरे खाता देख टिल नाउ जाका आस आ एटा टाइम अछि हम हातरे एनफ टाइम अछि. आमे नेक्स्ट क्लास को आसे पूर्वरु पूरा फंडामेंटल स्ट्रांग हे कि आसीथिबा. ओके, आ फोर्थ चैप्टर जेमति मु कहितली जे वेक्टर एडिशन इज टू इम्पोर्टेंट. वेक्टर एडिशन जदी न पढिछ गुरु आउ थरे ई टाइम भितरे फ्री अछ भलो कि पढि आस. वेक्टर एडिशन फर्स्ट ईयर रो वेक्टर एडिशन केमति हमें वेक्टर ऐड करूचे, different problems of the vector addition, all will be applicable here. Okay, not only in this, only electric force, in the next chapter electric field intensity also vector addition is important. Okay. So this was all about what we have studied previously. Again I have a problem भी करथिले regarding the electric force. Okay, केमती दीटा बॉडी भितर फोर्स केमती हबो, how if the more than two bodies are there, how the force will vary. So different problems हम करथिले. तापरे तुमको problem भी देइथिली, हम 7-8 problem देइथिली. No doubt all of you have solved all the problems, but hope हमें आउथरे करिबा. And one more thing, I have also given you some assignment, like what are the difference between electric force and gravitational force. Also you have given okay, only I think only one assignment I have given, the difference and the similarities between the electric force and gravitational force. Okay, let's discuss some of the differences and some of the similarities. So in difference, one difference between the gravitational force and the electric force is gravitational force is always attractive, but electric force may be attractive, may be repulsive. Another difference is gravitational force does not depend upon the medium. Its value is always same for different mediums. If the two bodies are constant, the mass of the two bodies remains same, and the distance between the two bodies remains same, the value of the gravitational force is also same. It does not vary with the medium, but the value of the Coulomb's force varies with the medium. These are very two important differences. Okay, another difference we can take it as the gravitational force is very long range force, but electric force is not so long range force. Electric force is stronger than the gravitational force. Okay, these are also some differences. One more thing, maybe ମୁଁ तुम क्लास रे कहि पारिनी जे if the distance is very small, if the distance between the two charged particles is very small, no doubt the electric force is stronger. If the distance between the two charged particles is very small, distance between two charged particles, let it equal to R. So force equal to how much? Beta Q1 Q2 by R square, or you can say force is directly proportional to 1 by R square, or you can say force is inversely proportional to R square. If the distance between the two charged particles decreases, force will increase. Okay, so up to how much, up to distance कम कम केते पर्यंत आसीबो, पूरा लागि जिवो दिटा बडी शॉर्ट हो जिवो, पॉजिटिव नेगेटिव चार्ज में भी शॉर्टेड. Okay, so no doubt distance कमिले force बढ़िबो, distance कमिले force बढ़िबो, but the distance should not be less than equal to, the distance should not be less than equal to 10 to the power minus 15 meter. 10 to the minus 15 meter, or we can say if the distance is less than equal to 10 to the power minus 15 meter, Coulomb's law is not applicable. There will be no electric force between the two charged particles. In that times, some different force comes into arise, that is nuclear force. We'll discuss it later. Nuclear force, our physics last to kochi am padheba. So exactly what happens inside the nucleus? No doubt inside the nucleus there are protons, there are neutrons. There is no charge between the neutrons, so there will be no force between the neutrons. But the protons, all the protons are positively charged. All the protons are positively charged, are placed in a compact space inside the nucleus. So there must be some repulsive force. The protons must go away from each other. The protons must go away from the nucleus, but that does not happen inside the nucleus. Rather, the protons are attracted between each other. So the force between two similar charged particles can never be attractive according to our Coulomb's force. Okay, so definitely that is not the Coulomb's force. That is some different type of force, and it was called as nuclear force, and we will discuss it later. Okay, so if the distance becomes less than 10 to the power 15 meter, minus 15 meter, then Coulomb's law is not applicable. Okay. So देखिए आमे प्रॉब्लम सब कोन देइथिले, 7-8 टा प्रॉब्लम देइथिले, नो डाउट तमान सब करथिबो प्रॉब्लम सब. हां, आमे सब डिस्कशन करिवा ना ओनली नंबर 8 डिस्कशन करिवा. Some of you have raised that number 8 question should be discussed in deeply, sorry. हो छाड़ो मु 3-4 क्वेश्चन डिस्कशन कर दोची. एक नंबर क्वेश्चन कोन देथिले देखो, 2 charges plus q and plus 2q are placed at the ends of a straight line. Two charges, this is a straight line. Here one charge is Q plus Q, and here plus 2Q are placed at the ends of a straight line. Another charge plus Q is placed at the midpoint. Another charge plus Q is placed at the midpoint. Okay, then option was what will happen to the charge placed in the midpoint? What will happen to it? Okay, ये कौन करिबो अभी जते बेले दीटा चार्ज फिक्स ही के अछि दीटा एंड रे गोटे स्ट्रेट लाइन रो मझिरे आमे कोन करले गोटे प्लस क्यू चार्ज आनि के रखिले ताले डेफिनेटली आपरो फोर्स पड़िबो, इलेक्ट्रिक फोर्स पड़िबो, एंड दिस चार्ज ये चार्ज कोन करिबो ताकू एबुटू रिपेल करिबो. लेट दिस फोर्स इज क्यू आउ ए चार्ज कोन करे ताकू एबुटू रिपेल करिबो. लेट दिस फोर्स इज F2Q. किंतु तमान को ए फोर्सटा बड़ा होबो ना, ए फोर्स बड़ा होबो, डेफिनेटली दिस फोर्स इज ग्रेटर. Sorry, I'm sorry. This force will be greater. Why this force will be greater? Here the force will be, the force between these two charge particle will be beta Q1 Q2 by R square. As the charge is the charge is 2 times the charge of this one, so this force will be 2 times the force of this one. So definitely the charge particle will move towards this. The charge particle will move like this. Then after some distance, these two forces will remain equal. Okay, because there will be the distance will change. For this distance will increase, so the force will decrease. For this the distance will decrease and the force will increase, and finally the two forces will remain. The two forces will be same and it will cancel each other. Okay, so the charge particle will be at rest. Okay, आमे Coulomb's force रो सब different properties पढ़ी थिले, सेटा हम कहे भूली अछि तुम केबे. different properties of the Coulomb force कोन सब property थिला. गोटे property थिला Coulomb force is a central force. Coulomb force is a central force. Another property was Coulomb force is a mutual force. Okay, another property was Coulomb force is conservative force. Upon thila central force, mutual force, conservative force. It may be attractive, may be repulsive. It depends upon the medium. Okay, and okay, like this there is the properties of the Coulomb, and a Coulomb force will not be applicable if the distance is less than 10 to the minus 15 meter. Oh, अब कौन problem थिला. number 2 question. A charge small q, मतलब लागुच तुम देखा जाऊ नथिबो. ओके, तुम बार क्वेश्चन अछि, यू कैन रेफर दैट क्वेश्चन. आमे देइथिले सेंड करथिले. A charge small q is placed at the center of the line joining two equal charges capital Q. This system of 3 charges will be in equilibrium if small q is equal to how much in terms of capital Q. Okay, so question is मतलब ये क्वेश्चन हमें क्लास रे डिस्कशन भी करी चे मो मन पड़नी. सो गोटे लाइन अछि, here charge is equal to capital Q, here charge is equal to capital Q. In the midpoint another charge particle small q will be placed, and question is all the 1 2 3 all the 3 charge particles will remain at equilibrium. equilibrium, then what is the relation between this small q and capital Q? Okay, let's see the small q charge particle is exactly at the middle between the two large particles, between the two charged particles. Okay, if this is positive, this is negative, and this is positive, so this charge particle will be attracted towards this charge particle will also attracted towards this, and the attractive force will be same. Why same? Because the force between these two charge particles, small q, capital Q distance, and here also say small q, capital Q distance is same, that is why the force will be same, attractive force will be same, so the small q charge particle will be at equilibrium. If the force will be repulsive, also the small q charge particle will be at equilibrium. So এটা আমি কাহি ডিসকাশন করছে because we need not worry about the small q charge particle. As it is placed at the middle between two equal charges, definitely it will be at equilibrium. Only we will discuss about what the equilibrium of this capital Q charge particle. Okay, the capital Q charge particle the equilibrium re rahila, a capital Q charge particle equilibrium rahibo. Okay, so all the three charge particles will be equilibrium, and we can say the system of the charge particles will be at equilibrium. So capital Q charge particle upare kon force achi dekhla, dita force achi. One force is due to this small q charge particle, another force is due to this capital Q charge particle. Okay, so due to this small q charge particle, the force again two forces balances each other. That means the two forces must be equal and the two forces must be opposite. Okay, how the two forces will be opposite? One force is between these two charge particles, another force between these two charge particles. The two force will be opposite. Again, these two charge particles are equal charges, so this must be repulsive. This must be repulsive. So this is the force on this charge particle due to this capital Q charge particle, and I can write it as F capital Q. Okay, so this charge particle ये कौन करथुवार अछि को, ये तब F2 को attract करथु. So this is the force applied on this capital Q charge particle due to this small charge Q particle. So this force is attractive. That means this charge particle is attracted towards this small q charge particle. So definitely, if this is positive, this must be negative. And if this is negative, this must be positive. Okay, so chhada, so negative positive kotha chhada. So these two forces must be equal. Okay, if these two forces will be equal, definitely this capital Q charge particle will be equilibrium. If this capital Q charge particle will be equilibrium, this must be at equilibrium. And already we have discussed the small q charge particle will definitely at equilibrium, so you can say the system of the charge particles will be at equilibrium. Okay, tale ei dita charge particle is same. What is the magnitude? What is the force on this charge particle due to this? Equal to 1 by 4 pi epsilon 0 q1 q2 divided by, let this distance is equal to r divided by r square. Okay, and what is this force? This force is equal to 1 by 4 pi epsilon 0 q1 q2 divided by this r square. What is this r? R by 2. q1 q2 divided by r by 2 square. All will be cancelled. Capital Q. It implies q by r square is equal to small q r square by 4. 4 becomes 4. Hele kon hela dekhla koti gala. It implies capital Q is equal to 4q. So pachache what will the value of the small q? So it implies small q is equal to q by 4. Again, already we have discussed, if it is positive, this will be negative. If this is negative, this will be positive. Or you can say this is equal to minus. Okay, so answer will be small q is equal to minus capital Q by 4. Okay, मते लागुची आउ सब क्वेश्चन तमर हे जाइथिबो हैं खाली 8 नंबर क्वेश्चन टा कर देले हमें क्लियर हो जिबा ए सब 7-8 क्वेश्चन रे एमती नेक्स्ट भी मु तुम गोटे गोटे क्वेश्चन दउथिबी तुम मन तार आंसर करि दउथबो जो क्वेश्चन न होथबो तब हिंट्स दे दउथबो आमे डिस्कशन कर दउ तुम कहि दउथि तापर नेक्स्ट वीडियो रे जे क्वेश्चन आंसर केमती हो ओके हो 8 नंबर क्वेश्चन पांचो देखे देखि दियो क्वेश्चन कोन अछि 8 नंबर क्वेश्चन कहया पूर्व मु तुमको आउ गोटे जिंस कहूची अगेन से टाइम हम पढ़ीची इलेक्ट्रिक फील्ड विषय रे बहुत कम पाठ पढ़ीचे इलेक्ट्रिक फील्ड विषय रे नो डाउट ये से टिके रुही आसी क्वेश्चन ता कोन पढ़ीचे कहला हम इलेक्ट्रिक फील्ड विषय रे इलेक्ट्रिक फील्ड और इलेक्ट्रिक फील्ड इंटेंसिटी and its symbol was capital E. It was a vector physical quantity. तार यूनिट कौन पढ़ी थिले तार डायमेंशन कौन भी पढ़ी थिले तार डेफिनेशन कौन भी पढ़ी थिले जस्ट लुक एट द डेफिनेशन कौन थिला नो डाउट इलेक्ट्रिक फील्ड आउट डेफिनेशन थिला आई एम टॉकिंग अबाउट द डेफिनेशन ऑफ द इलेक्ट्रिक फील्ड इंटेंसिटी एट ए पॉइंट due to देखो तो खाता लिखा है तमरो इलेक्ट्रिक फील्ड इंटेंसिटी एट अ पॉइंट ड्यू टू ए चार्ज पार्टिकल मे बी ड्यू टू ए चार्ज पार्टिकल मे बी ड्यू टू ए सिस्टम ऑफ चार्ज पार्टिकल मे बी ड्यू टू सम चार्ज डिस्ट्रीब्यूशन हला चार्ज डिस्ट्रीब्यूशन विषय कहबा केते होतला ना इक्वल टू हाउ मच इक्वल टू द फोर्स पर यूनिट चार्ज इक्वल टू द फोर्स पर यूनिट चार्ज at that point if a foreign charge particle will be placed at that point. Okay, so at this point what will the electric field intensity if at this point a charge particle will be placed. Let a charge particle q is placed at this point or q0 charge particle is placed at this point okay, and the force on this charge particle is found to be F, then it implies the electric field intensity equal to force by Q0, or you can say force on this foreign charge particle, the force on this charge particle is equal to Q0E. Already हमें एवढा वाला फॉर्मूला कहिचे force is equal to QE. ओके ए गोटा कर व्यवहार हम करचे नंबर 8 क्वेश्चन रे so what is the conclusion if a charge particle will be placed in a electric field then force will be applied on that charge particle and that force will be equal to the product of the magnitude of that charge which is placed in the electric field and the electric field previously present at that point. जदि गोटे चार्ज पार्टिकल को गोटे इलेक्ट्रिक फील्ड में रखिबा ताहले से चार्ज पार्टिकल उपरे फोर्स पड़िबो केते फोर्स पड़िबो से चार्ज रो मूल्य गुणन इलेक्ट्रिक फील्ड क्वाडी फोर्स पड़िबो ना द डायरेक्शन ऑफ द फोर्स इज इक्वल टू द डायरेक्शन ऑफ द इलेक्ट्रिक फील्ड ता जुआडी के अछि सेडी फोर्स पड़िबो. It is not correct always. Okay, after going to G, force is equal to Q into E. So the direction of the force is equal to the direction of the electric field if this charge is positive. Okay, जदि positive charge particle टा में रखिबा electric field रे से positive charge particle ऊपर force क्वाडी पड़िबो electric field आडी पड़िबो. जदि negative, if this is negative then it is opposite direction, then we can write force equal to minus q into electric field. This means the direction of the force and the direction of the electric field is in opposite direction. Okay हो देखो क्वेश्चन देखो क्वेश्चन कौन थिला an electron of mass me, okay, mass of electron is taken as me, initially at rest, moves through a certain distance in uniform electric field, moves through certain distance in uniform electric field. Uniform electric field means this electric field is always constant. If this electric field is always constant, force will be constant. That is the difference. In non-uniform electric field, if the electric field varies, force will also vary. Okay, but here it is the uniform electric field. It takes time t1. Okay, then what? Then a proton is taken whose mass is mp. It was also initially at rest. Takes time t2 to move through an equal distance in the same uniform electric field, that is also uniform. Okay, neglecting the effect of gravity, find out the ratio T2 by T1. T2 means time taken by the proton, T1 means time taken by the electron. Okay. ताले क्वेश्चन कौन देची जे गोटे इलेक्ट्रिक फील्ड रे गोटे प्रोटॉन को आम छाड़िले आ गोटे इलेक्ट्रॉन को आम छाड़िले यूनिफॉर्म इलेक्ट्रिक फील्ड रे, both were at rest and both has to cover equal distance. Okay, both has to cover equal distance and time taken is different. For electron it was T1, for proton it was T2. Then what will the ratio of this T1 by T2? Let this is the uniform, generally uniform electric field. Let here is the uniform electric field. Okay, and the direction of the electric field is in this direction. आम कौन करवा ये गोटे अच्छी गोटे इलेक्ट्रॉन. लेट हियर इज एन इलेक्ट्रॉन इज प्रेजेंट. जदि हम इलेक्ट्रॉन इज एट रेस्ट, इलेक्ट्रॉन एटी छाड़ी दबा, इन व्हिच डायरेक्शन दिस इलेक्ट्रॉन विल मूव. नो डाउट एटा क्वेश्चन देइनी, क्वेश्चन पचरा हेनी, किंतु को जे इलेक्ट्रॉन ए को डायरेक्शन मूव करबो, इलेक्ट्रॉन ऊपर फोर्स पड़िबो. ओके, फोर्स इज इक्वल टू q into e. E the value, let the value of the E is given. What is the value of the charge of electron? Q is the 1.6 into 10 to the minus 19 coulomb. Okay, so there will be a force on this electron. But question is, in which direction this force will be applied? As the charge is negative, force equal to how much? Force is equal to Q into E. Okay, here it implies force equal to Q minus 1.6 into 10 to the minus 19 into E. So the direction of the force will be in the opposite direction of the electric field for the electron. So in this direction electric field is there, so electron will move in this direction. Okay, let the electron moves from this point to this point. Let that distance is equal to s. In how much time electron moves? In t1 time. This is given in the question. Electron is starts from rest and moves certain distance, let equal to s in time t1. Okay, next part was what? If a proton will be, let the proton is placed at this point, proton, definitely proton ऊपर भी force अच्छी, quadratic force अच्छी. Proton ऊपर force जब हम डिस्कशन करें, force is equal to Q into E. Charge of proton is positive, so the force on the proton will be in the same direction of the electric field intensity. So proton ऊपर force पड़े ऊपर ही towards the electric field intensity. Okay, so the force on the proton will be in this direction. Let the proton again moves from this point to this point. Same distance. Electron जेतिक distance जाइछि, proton भी सेतिक distance गला. केते टाइम रे जाइछि? T2 टाइम रे जाइछि. ओके, तापर हमें देखिबा जे T1 और T2 रो रेशियो केते होछि. ओके, ताले एबे ए केस कथा देखो. ए इलेक्ट्रॉन केमते मूव करछि ता कथा देखिबा. तो इलेक्ट्रॉन रेस्ट टू मूव करछि, सो इनिशियल वेलोसिटी फॉर द इलेक्ट्रॉन इज इक्वल टू 0. Initial velocity for the electron is equal to 0. Distance covered by the electron is equal to s It has taken time how much? T2. And what is the acceleration? We don't know. Acceleration of the electron, time, it has taken time T1. Acceleration of the electron, we don't know. We can take it as force by mass, or force on the electron by mass of the electron. What is the force? Force is equal to Q into E. Force is equal to Q into E divided by mass of electron. What is Q? Charge of electron. 1.6 into 10 to the power minus 19 into E divided by mass of electron. Okay, this is the acceleration. This value is the acceleration. So, what is the time taken T1? From which equation? U is given, S is given, T1 time is asked, and acceleration is given. We can put the equation of motion as S is equal to ut plus half a t square. Here initial velocity equal to 0. So it implies we can write S is equal to half a t square. Okay. So we want to find out the time. It implies t square equal to 2s by a. It implies t equal to 2s by a root over. It implies T1 equal to how much? T1 time taken by the electron is equal to root over of 2s divided by acceleration. What is the acceleration? This one is the acceleration. 1.6 into 10 to the power minus 19 into E divided by mass of electron. This are equal to root over of this mass of electron can come to the numerator. So 2s mass of electron divided by 1.6 into 10 to the power minus 19 into E. So this is the time taken by the electron. Time taken by the electron to cover this s distance. Like this we can find out the time taken by the proton to cover the same distance. What will be the time taken by the proton? In the same formula you can apply the force on the proton. Same thing. Force on the electron is same as the force on the proton. Mass of the proton is different. Okay. So here what will change? Only this one will change. Mass of the proton. Again here what will change? So time taken by the proton T2 can be written as 2s mass of the proton divided by 1.6 into 10 to the minus 19 into E root over. Okay. Now what will be the ratio? T2 by T1 सब कटि जीवो. T2 81 कौन आसे देखला? T2 81 देछि ना T1 by T2 देछि? T2 हाँ T2 by T1 कौन आसीबो सब कटि जीवो खाली रहइबो mass of proton divided by mass of electron root over. Okay, नोटा टी लेंदी अछि किंतु दिस क्वेश्चन आस्थला केबे केबे आईआईटी रो मल्टीपल चॉइस क्वेश्चन आस्थला बहुत इंपोर्टेंट क्वेश्चन. ओके तमे सुनो आज आम कि नुआ पाठ पढ़ेने जहाँ टू डिस्कसन करते से जिन कहले प्लस क्वेश्चन गोटे डाउट था कहले आम इलेक्ट्रिक फील्ड जहाँ डेफिनेशन जहाँ टी पढ़े नेक्स्ट क्लास ऑनवर्ड्स आम पढ़ेबा विल कंटिन्यू एंड अगेन आई प्रॉमिस दैट तुम आसिले क्लास रे आम आउ थे पढ़ेबा. ओके